We are going to review the elimination method today. We did graphing and substitution in the video for last time. So this time we're going over elimination. So remember the elimination, everything needs to be lined up. So for our first one, x's are lined up, y's are lined up, and then our numbers are lined up. What do we need to have in order to eliminate a letter? The same value except opposite signs. So looking at this first one, I think the y's are going to be the easier one to eliminate if I make this a -3, because then 3 plus -3 gone. So I'm going to multiply that equation times -3. So my first equation does not change. My second equation, I'm going to multiply everything times that -3, so that becomes -6x minus 3y equals 21. That's a negative sign, not a dot. So once we have it set up that they're the same values, just one's positive, one's negative, we can then add our two equations together. So 3x plus -6x gives me -3x. The y's cancel, and then -9 plus 21 gives us 12. So divide by -3, and what does x equal? All right, so I have my x value. I need to find a y value now. So I'm going to take my -4. I'm going to plug it into this equation. So 2 times -4 gives me a -8. And then plus my y equals -7. Add my 8 over, and I get a 1. So x is -4, y is a 1. Does that seem familiar now? Yeah. It even works no matter what your exponents are. So looking at our second example, what kind of equations are both of those? Yeah, those are circles. We got x squared, y squared. So we got two circles here. So we got to eliminate one of them. Stop. So which one do we want to go with, x squared or y squared? I'd go with y's because they're already with positive and negative. I just need to make the coefficients the same. So I would multiply this one times 2, because that's going to make that a -6. And then I multiply that one times 3, because then that would make that a +6. 4x squared minus 6y squared. 1023. So again, add them together. Y squared cancel. We get 13x squared equals 1053. Divide by 13. And what does x squared equal? 81. So then I take the square root, and what does x equal? Plus or minus 9. Remember, when you take that square root of both sides, it's always plus or minus. So now we got to plug that in, get our y values. So we got to plug in a +9, and we got to plug in a -9. So I'm going to use my first equation up there. So that's going to be 2 times 9 squared minus 3y squared equals 15. So 9 squared is 81 times 2 gives me 162. 162 minus 3y squared equals 15. So then subtract our 162 over. And what do we get? negative 147. Divide by negative 3. And we get a 49. Square root it. Plus minus 7. So that gives us the 0.9, positive 7, and 9, negative 7. Now what's going to happen when we plug in the negative 9? It's going to end up being the same exact thing. So then we get negative 9, positive 7, and negative 9, negative 7. All right, so questions on the process? Okay, so we're going to take that process and we're going to apply it to what we call 3x3 systems. It's got 3 variables and it's got 3 equations, so hence the name 3x3. And really it's the same thing. You've got to do elimination method over and over and over again. So if we take a look at my first example here, I have my 3 equations. I labeled them as 1, 2, 3. So if I tell you I'm looking at equation 1, we all know which one I'm talking about there. So what we want to do is we have to decide which of the 3 letters we can eliminate first. And a lot of times if you look at it, you can find one letter that's going to be a little easier than the other 2. So like for example here, if I look at my z's, those look like they're going to be the easier ones because they're all a coefficient of 1. You got one of them that's a positive already. The other 2 are negatives. So I'm going to go for my z first this time. So I'm going to take equation 1. And I'm going to add equation 2 to it. So equation 1 plus equation 2. When I do that, my z's will eliminate just like what I wanted it to. So 2x plus 6x is 8x minus 2y gives me 50. And I'm going to call that new one that I just got by adding those 2 together, I'm going to call that equation 4. 8x minus 2y equals 50. And it's only got 2 variables now. So then what I have to do is I then have to try to eliminate the letter z again. I can't use equations 1 and 2 because I've already done that with equations 1 and 2. So this time I would do it with equations 1 and 3 because my z is already set up nicely in equation 1 and in equation 3 to cross each other out. So I'm going to go through the same process with equation 1 and equation 3. So I'm going to set up to add equation 1 and equation 3 together. So when I add them together, I get negative 2x plus 5y equals a 1. And I'm going to call that equation 5. So now, number 4 and number 5 both have 2 letters. They're both down to an x and a y. So that goes back to what we were just doing. I'm going to line them up. So I'm going to line up my x's, line up my y's with my 2 new equations that I just made. And I think it's probably going to be easiest to eliminate x. If I multiply my negative 2 by a 4, so again, my first one stays the same. The negative 8x plus 20y equals a 4. So when I add, my x's cancel like I wanted. My y's give me an 18. And then 50 plus 4 gives me 54. So divide by 18, what does y equal? 3. So I got one of them. Y is a 3. So now I'm going to take that value of 3 and I'm going to plug it into either equation 4 or equation 5 because those ones only have x's and y's in it. So if I plug it into one of those two, I'll be able to get a value for x. So I'm going to actually use equation 5, so negative 2x plus 15 equals 1, because 5 times 3 is where my 15 came from. Subtract my 15 and I get negative 14. Divide by negative 2, and we get x is 7. So now we got two of them. We just have to go back and find our third one. We've got to find what z is going to be equal to. So now we go back to the original 3. You can pick any one of those original 3. It does not matter which one. And you're going to plug in your x and your y values. So I'm going to use equation number 1. So 2 times x, so that's 14, plus y, which is a 3, plus z equals 15. So again, just plugging in my two values into that first one. 14 plus 3 gives me 17. Subtract my 17 over, and we get z is negative 2. All right, let's try it again. So let's look at our 3 equations and try to figure out which letter is going to be the easiest to eliminate first. I think probably the y's, yeah. Because right off the bat, if I use equation 1 and equation 3, I can already get the y to knock out. So I'm going to start with those ones. So 4x plus y minus 3z is negative 6. Minus 7. Z equals negative 19. So again, line them up, then those y's will cancel each other. 4 plus 5 gives me x minus 10z equals negative 25. So what 2 equations should we use next? I would probably go with 2 and 3. But equation 3, we would have to multiply by what? 4. Because then I could get that negative 4y, so it'll cancel with the one from the second equation. So my second equation stays the way it is. My third equation, everything gets multiplied by 4. So that's 20x minus 4y minus 28z equals negative 76. So my fifth equation ends up being 18x minus 26z equals negative 38. So then I'm going to line up my 2 new equations. Line up my x's, line up my z's. There we go. So what letter do you think we should eliminate next? Yeah, I think x is probably going to be the easier one. What should we multiply that first equation by? Negative 2. So negative 18x plus 20z equals 50. So x's cancel, I get negative 6z equals 12. So what does z equal? -2. I'll probably use equation 4 just because those coefficients are a little bit smaller to figure out what my value of x is going to be. That would give me 9x plus 20 equals a -25 when I plug in my -2 there. Subtract my 20, divide by 9, and we get the x is a -5. So we just got to find our last one. We got to find our y. So again, you got to go back to one of the original 3. I'll probably use the first one. So that's 4x, so that's going to be -20. So it's 4 times a -5. Plus y plus 6, because it's -3z, so -3 times -2 makes it +6. Equals -6. So -20 plus the 6 on the left makes it -14. Add my 14 over. And we get y equals 8. All right, so like the notes say, next one, you try. Try to do that one on your own. Does not matter which letter you choose to eliminate first. You should always end up in the same spot if you do your algebra right. All right, how'd we do? X should be a -1, y should be a -3, and z should be 7. I'll go ahead and on there. All right, I'll give you another minute. Finish that one up if you need to. All right. Let's take a look at this last one here. I'm not going to lie, this last one's going to be a little bit of a doozy. So we've got our general equation for a circle up there. X squared plus y squared plus dx plus ey plus f equals 0. It's the same equation I showed you a few days ago, just they took out the coefficients of a, b, and c. But still the same thing there. So what they want us to do is they want us to write an equation for the circle. I highlight that because we got to remember that's our ultimate goal. We're trying to write the equation for a circle passing through those 3 points, 5, 3, 6, 2, and 3, -1. We can't write the equation of the circle until we know what D, E, and F are. So in order to do that, we have to come up with 3 equations using the 3 points, and then we do the elimination like we were just doing on the other ones for the 3x3s. So starting with my first point here, 5, 3, I'm going to plug 5 in for all of my x's, and I'm going to plug 3 in for all of my y's in the general equation for a circle up there. So that's going to be 5 squared plus 3 squared plus b times 5 plus e times 3 plus f equals 0. So then we'll clean this up a little bit. What is 5 squared? And then 3 squared. When I add 25 and 9 together, that gives me a 34. But like with our other equations, that number generally is on the other side of the equal sign, so I'm just going to move that over. So I get 5d plus 3e plus f equals -34. And there's my first equation that I'll use in my 3x3 system. So now we have to do that same process again, but now with our second point, the point 6, 2. So I'm going to put 6 in for all of my x's, 2 in for all of my y's. So 6 squared plus 2 squared plus d times 6 plus e times 2 plus f equals 0. So I'm cleaning this up. 6 squared is 36 plus 2 squared, which is 4, gives me a 40. So I get 6b plus 2e plus my f equals a negative 40. So I'll subtract my 40 over to the other side. So now I have my second equation. So then third one, we've got to plug in that third point there. Point R, which is 3 comma negative 1. Be careful when you're plugging in that negative 1 when you're squaring it. That's going to turn positive. So 3 squared plus negative 1 squared plus d times 3 plus e times negative 1 plus f is 0. 3 squared is 9, negative 1 squared is 1, so add those together, that gives me 10. So 3d minus e plus f equals a negative 10. There's our third equation. So our 3 points gives us our 3 equations. So I'm going to line them up over here. Just because lining them up sometimes makes it a little easier to see what we're doing. So if we look at our 3 equations that we just made, which letter is going to be the easiest one to knock out probably? F, because those are all coefficients of 1. So I'm going to multiply this second one here times negative 1, and I'm going to add it to my first one. That gives me negative d plus e equals 6. So that's not equation 5, that's equation 4. So there's my equation 4. So I'm probably still going to multiply my second one times the negative 1, but then I'll just add it to my third one this time. So then my second equation times negative 1 still is negative 6d minus 3e minus f equals 40. I'll leave my third one the way it is. And then add the 2 of them together. Still is going to get rid of my letter f there. That gives me negative 3d minus 3e equals 30. So looking at our new ones, equations 4 and equations 5, probably going to be e's because I have a positive e there, and then I have that negative 3e there. So what would I have to multiply this one up here by? 3. That makes it negative 3d plus 3e, not e, equals 18. You can line up question number 5 underneath it. So we get negative 6e equals 48, so what does b equal? Negative 8. Now I gotta find my E and my F. So I'll probably use equation 4 because that one's a little bit easier. So if I plug my negative 8 in here, that gives me positive 8 plus E equals a 6. So subtract my 8 over and E equals negative 2. Then we got one more. Let's see here, which equation is probably going to be easier? Probably the third one, the 3D minus E plus F equals negative 10. So 3 times D is negative 24 plus 2 because it's minus E, so minus negative 2 plus F is equal to negative 10. So negative 24 plus 2 gives me negative 22. Add that 22 over, and what does F equal? 12. Now remember, we're still not done yet. The whole point of this was to write the equation of the circle, which I can do now that I know D, E, and F. So x squared plus y squared minus 8x minus 2y plus 12 equals 0. There's our equation. All right, one more. The sum of two numbers is 5, and the larger difference of the two numbers is 39. Find the two numbers by setting up a system of two equations with two unknowns and then solving algebraically. Let's see. So I'm going to say let x equal a number. There's one unknown. And I'm going to say let y equal a number. There's my second unknown. So that takes care of the two unknowns. So let's write some equations. The sum of two numbers is 5. Sum means we're doing what? X plus y equals 5. The larger difference of the two numbers is 39. X minus y equals 39. It's already set up for elimination, so just add them together. Y's cancel. 5 plus 39 gives us 44. So what does x equal? 22. So if I plug 22 back in, what does y end up equaling? Negative 17. So now the reason why it said the larger difference is because if I do 22 minus negative 17, it ends up adding and gives you 39. But if I subtract them the other way, I get negative 39. So 39 is just large. It was trying to help you tell you which way to set up your equations there. So we always need a sentence for word problems. The numbers are 22 and 17, negative 17.